So this is a video on 10.2, and 10.2 is about linear equations. What that means is that linear means that when you graph it, it's going to be a line. Equation, they're going to give it to you in equations sometimes, they're going to give it to you in a graph sometimes, and in a table sometimes. So say they give you an equation, y equals 2x plus 7. That will make a straight line. They don't really tell you too much about why it makes a straight line or what wouldn't make a straight line, but basically if you have an exponent on your x or your y that's greater, this is the exponent that's greater than 1, because really there's a little 1 right here that's understood. If you have an exponent that's greater than 1, you're going to get a graph that's not going to be a straight line. So like this, probably in the next 2 or 3 math classes that you take, if you take them, they graph what's called in a parabola shape, so they look like a smiley or a frown. You don't really care about that. What you care about on this class is that they're going to mostly focus on lines, linear equations. So if you have a linear equation, most likely it's going to have an x and a y and a number. And the x, I put the little 1 on the wrong one, although the 2 does have a 1. There. The x is going to have an exponent of 1. Okay? So if I just talk about graphing this, if you're ever not sure if it makes a line, all you have to do is make a table. So let me show you how you do that. And on a table, you get to make up whatever x's you want and then solve for y. So what I mean by that is pick a number for x. I usually pick like 0 first because it's really easy. If I pick 0 for x, if I take the original equation and I rewrite it, but instead of that x, put a 0. I can solve the right-hand side, and 2 times 0 is 0, plus 7 is 7. So every time 0 is put in for x, I'm going to get 7 as a y. So I go over here and put 7. This corresponds to an ordered pair. You know how like on the last video we talked about ordered pairs and how you graph them? This would be an ordered pair 0, 7. So the 0 would be your x, the 7 would be your y. So you go 0 on the x, and you go 7 on the y, 3, 4, 5, 6, 7, and you put a dot. Oh, that's not really on 7, but you get the idea. So I can put another value in to try to see if it's going to make a straight line. So again, I would just pick small numbers. If I put a 1 in for the x, then I'm going to erase this. And I'll erase this because it will no longer equal 7. Okay. So now I'm going to put a 1 in here. So 2 times 1 is 2 plus 7 is 9. So now y equals 9. So every time a 1 goes in, oops, as I write 2. Ooh, late day. A 9 comes out. So then I can graph that. When x is 1, y is 9, so it would be somewhere up here. You know, I'm faking it because I don't have graph paper on here right now. But so I can put another number in, let's say, and I'm just making up these numbers. You can make up whatever x you want, and then once you put it in, it forces it to be a y. And so like maybe I put -2 in here. So again, I erase this, and I put a -2. And you can do this part in your calculator. Okay, so 2 times -2 is -4. And -4 plus 7 is 3, so y equals 3. Utilize your calculator on this because you do get that scientific calculator for the final. And you don't want to make like simple adding and multiplying errors. Each problem on the final is worth 5 points. And if they see that you made a simple error, they take 1 or 2 points off, but that can all add up. Okay, so now I'm going to graph the points -2, 3. So -2 on the x and +3 on the y. And you can see off my rough graph, I can't graph it, that it's starting to make a line. So this is a linear equation because if I put more points in and more points and more points, I will get more points along this line. Pretty soon all those points will be so close together that they then make a line. Okay, so let's try another one. Let me see if I can put some graph paper in here. There we go. Okay, so if I take another equation, let's say y equals negative 3x, and let's just leave it at negative 3x. If I asked you to graph that, then you would make an x and y table. And there's other ways to graph too, and we learn those later where you don't have to make the table. Some calculators will make the table for you. I'll have to look and see what my calculator is. A graphing calculator will for sure, but I think like the TS30XS Multiview, which is a really good one to have, that's just a basic scientific one, it'll make this table for you. You can enter this equation in and it will give you all the values. It's kind of sweet. So, and they're like $10. So I'm going to make up a number like negative 3. Okay, so then up here I'm going to pretend like the x is a negative 3. It's like these are functions. The equation is called a function, and it's like you have this, we used to call them function machines, and so when I teach it like at the middle school, I'll tell them, you know, a number is going in. The negative 3 is coming into the box. Every time something goes into the box, it multiplies it by negative 3, and the y comes out. And so if negative 3 goes into the box, you get negative 3 times negative 3, which is 9. So then you would get 9. So you can go back to this idea again, and I can say, okay, well, what if 0 went into the box? If 0 goes in, the box is always going to take negative 3 and multiply it times whatever's coming in. Negative 3 times 0 is 0, so 0 comes out. And again, I'm just making up whatever x I want. 2. If 2 goes in, multiplies it by negative 3, and you get negative 6. So once you have like 3 or 4 points, go ahead and start graphing them. So 0, 0 is here. Negative 3, 9. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's hard to do a dot on here. And 2, 6. So 1, 2, negative 6. 1, 2, 3, 4, 5, 6. And if you get 3 points and they don't look like they're lining up, right? Do a 4th one, or if one looks funky, don't try and figure out what you did wrong. Just shove another point in there. So I'll put 4 in there. 4 times negative 3 is negative 12, so then I can go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I ran out of room. But you get the idea. Then, and always use a ruler on all your quizzes and your final, always. Okay, and then lines go on forever in each direction, so you put an arrow. So if I asked you to graph y equals negative 3x, that's what the graph would look like. The other thing that they ask you is, they'll ask you like, could this be a solution? They'll say, could 5, negative 15 be a solution to this equation? Well, so you test it out. You say, okay, well that means that the 5 is an x and the negative 15 is a y. So you look at the equation. Would that make, if I put a 5 in, would it make negative 15? Yes, it would. So yes, this is a solution. What does one look like that's not a solution? Maybe they give you, maybe they say, what if you put a 3 in, does a positive 12 come out? Would 312 be a solution? So you put a 3 in, y equals negative 3 times 3. No, that doesn't equal 12, so no, that's not a solution. Another way to find out if it's a solution, if it's a solution, and this is important to see that relationship, if it's a solution, it's going to be somewhere on this line if you graph it. So like the one that was a solution, 5, negative 15, if I made my graph long enough, if I went over 5 and down 15, it would be on this line. And 312, if I went over 3 and up 12, there's no way I would be on that line. I'd be way out there. And so I know that's not a solution. Solutions will be a dot that's on the line. Then the next thing that they do is they give it to you where it's not in y equals form. They give it to you where it looks something like this or some other form. Okay? So if it looks like this, solve for y first. So, you could take 2x and move it over. And you get 3y equals, and it doesn't matter if you put the 7 first or you put the minus 2x first. It just matters that the minus stays with the 2x. So you could write it this way, or you could write it this way. You do either one. Okay, so now I'm going to divide by 3. And if I do that, I have to divide both of these by 3. They will test that out on the final to see that you understand that. So y equals negative, and I can just call this 2/3 x, or you can leave the x up there if you want to, plus 7/3. So this would be my equation solved for y. And then if they wanted me to graph it, again, I could pick out numbers to put in for x. If I put 0 in for x, negative 2/3 times 0 is 0, plus 7/3 is 7/3. Sorry, I made this so ugly. Okay, and you could do other numbers. And you have your calculator, so don't get freaked out that they're fractions. So the textbook asks you to solve for y first. And then it asks you to do, to graph it or do whatever. So now there's, let's see, there's some problems. I'll try to follow some of your examples. They had an equation that looked like this. And sometimes they'll put a table this way. And I noticed on the problems that were on the computer, like they would already have numbers in here for you. And then you have to come out with the y's. Now you can actually plug these in while it's in this form. You don't have to solve for y. It's just easier. But let me show you what happens if you don't want to solve for y. If the directions don't say solve for y, you don't have to. So I could take this x plus y equals 5, and I could put a negative 2 in for x. So that would look like this. Negative 2 plus y equals 5. And then I could solve that by adding 2 to each side. And y equals 7. So I know that was a 7. Then I could put a 0 in. So I could go back to the drawing board. Whoops. And I could put a 0 in for x. And I could see that y would equal 5. And then again, I could put a 2 in for x. Minus 2 and minus 2. Y equals 3. So I don't have to solve for y first. Now, some people think it's easier, especially if it's a harder problem. Like if I have x plus y equals 5, the reason why some people like to solve for y is watch how easy this becomes. So minus x and minus x. Y equals 5, take away x, or you could say negative x plus 5, doesn't matter. But now when I plug, so say we didn't know these yet, now when I plug this negative 2 in, it's super easy because I can do it in my calculator. I can just go 5 minus negative 2. I don't have to use all this inverse operations to solve. So 5 minus negative 2 is 7, so equals 7. And then back to the drawing board, and if I put a 0 in there, 5 take away 0 is 5. And it becomes so much faster. But if you screw up on this part, everything's messed up. And so it's a choice that you make. If you're really good at solving for y, then solve for y first. If you don't feel comfortable, do it both ways and see what happens. If you don't think you're doing it right, what should these points look like if you graph them? They should be a line. So again, that's just that you need to make sure that you understand the connection between the table, the equation, and the graph. So one of the other things that will have different graphs, and it'll ask you which graph belongs to this equation. Or it'll have a table and say which graph belongs to this table. Okay, so the quickest way to solve these kind of problems is remember that graphs are points. So find some points on each graph where it crosses at a whole number, where you can name the ordered pair. So like this ordered pair is 0, -1, because we went 0 on the x and down 1 on the y. And then, let's see, this ordered pair right here is 1, 1. This ordered pair is 2, 3. And let's name someone here. This ordered pair is -1, -1. And 0, 1. And 2, 5. So if you wanted to know which graph went to this equation, remember the ordered pairs are just, well, let me draw the table the other way. I hate it when they're that way. Ordered pairs are just numbers out of a table. And so if I put these pairs in the table, 2, 3, 1, 1, 0, -1. So this table goes to this graph. Okay, and this one, 2, 5, 0, 1, -1, -1. And this goes to this graph. So whichever numbers make this equation true is going to work. So plug some in. Don't plug 1 in and assume that that's it, though, because sometimes they'll be tricky and the graphs will cross at a certain point. But like if I plug 2 and 3 in, I plug 2 into the x and see if 3 comes out. So 2 times 3 is 6, minus 1 is 5. And that wasn't real good because that's not true. 2 times, let me try that again. Let me give some room down here. Minus 1. There we go. Okay, so if I take those numbers and I plug them in, 2 times 2, this is why you should always write it down, because I tried to do it in my head and it was wrong. 2 times 2 is 4. 4 minus 1 is 3. So this one checks out. That makes it true. So let's try another pair. Sorry it got so squishy in here. It's so hard on this program. So I'm going to try 1, 1. 2 times 1 minus 1. Looks like an equals. 2 times 1 is 2. 2 minus 1 is 1. So this one works. And I can try the last one. And if it works, then this is the graph that belongs to this equation. Watch what happens when I try this one. Okay, so the equation was y equals 2x minus 1. So I'm going to use this point and plug it in. So 2 times 2 minus 1. 2 times 2 is 4. 4 minus 1. Nope, it's not 5. So then as soon as I find one that doesn't work, I can say, nope, that's not the graph. Because remember, every point on the line should make it true for that equation. And that's the end of section 10.2. Just let me know if you have other questions. There was a story problem at the end of the homework. Pay attention to that. It's hard for me to do the story problems on here because then I have to have a bunch of graphs and things like that. So on number 18 on the homework, make sure you let me know if you don't understand that. And let me know if you have any other issues. Thanks.